Okay, so we've looked at the perception of vowels, we've looked at the perception of different types of consonants, and now we want to look and see how we can draw some of this together into a general picture of how perception works. I'm going to start by talking about the motor theory of speech perception, or just motor theory. And this is in one of the reasons that we have this is researchers have always been trying to find what's invariant, what's the same across different productions of a particular sound, and how can we sort of pin that to the wall and work our understanding out from what stays consistent. Um, Acoustically, as we've seen, there's a lot of variability, and perceptually, there's a lot of variability in how our perceptual system keys into the different acoustic features to give us a percept or a recognized sound at the end of it. And so the motor theory aims to get around all of that by saying what's invariant is the articulation, and that somehow the articulation is part of not just producing the sound, but perceiving the sound. Okay, and there's various uh, ideas that come in to that to sort of feed that. The idea of mirror neurons. We do absolutely have some elements of our neural architecture that is designed to reflect the how things are done that we observe in the world. We see someone make a physical movement, and part of our brain mirrors that. It simulates making that physical movement itself in the areas of our brain that deal with generating physical movement. So not implausible. How can we do that? How can we have a model in our brain for how we articulate sounds? It's not like watching someone wave their hands where we can see the movement. Sounds have a slightly more indirect relationship to the movements that produce them. For example, sometimes there's multiple ways to produce the same sound. We see this with the alveolar and retroflex approximants, r and r. Sound very similar, even though in one the tongue is doing this, and the other the tongue is curling back and making close approach somewhere else. So you have multiple articulations that can produce the same sound. There's a couple other examples of that. So one approach to this in motor theory is to say what we're perceiving isn't the actual gestures, but the intended gestures. Of course, there's an alternative known as direct realism, a version of motor theory where the actual gestures are the units of perception. Maybe we just don't perceive them perfectly. A lot of interesting questions around that. And motor theory has been able to explain some patterns better than other approaches, and it has some shortcomings. One pattern that we do see across a lot of uh, instances in speech production is the idea of categorical perception. So we might expect, as we vary an acoustic cue that distinguishes two categories, that listeners' responses will vary in proportion to where that cue is on the continuum. What do I mean? Let's consider graphing. Let's say we change voice onset time in a set of artificial stimuli. So people are listening to these things and they hear voice onset time. It starts out maybe at a negative voice onset, so the voicing starts before the release, then at the release, and we vary it in say 10 millisecond units. Negative voice onset time in the language we're looking at, let's say, is associated with the voiced phoneme, voiced version, say ba. And so if people are given a choice, do you hear ba or pa? They will answer none or virtually none of their response will be say, I hear pa. But as we go along, we would expect more and more of their responses to be, yeah, I hear pa, not ba anymore. Until at the other end, with a very long positive voice onset time, very long aspiration, they're always answering, yeah, that's definitely a pa. This is what we might expect. What we see is more like this, where as the voice onset time changes, there's very little shift until we hit some transition zone where the perception changes very abruptly. There may be one uh, point on that range where people are really uncertain and they'll answer maybe half and half. but then very quickly you get to almost all of the answers being pa. So you get this S-shaped curve instead of this nice linear curve, linear response pattern. And so this is characteristic of categorical perception. Something in the brain is really forcing our perception into category A or category B, and it has crafted our perception so there's a boundary that we're very sensitive to that gives us that sort of abrupt S shape to that curve. Now that was an identification task. If you asked your listeners to say, which do you hear, pa or ba? There's other tasks we can do to look at this as well. One is there's a variety of tasks known as discrimination tasks. Can you discriminate between or tell the difference between two similar things? So let's say we're looking at here the two similar things might be you have a negative 10 millisecond VOT and a 0 millisecond VOT. Do they sound different or do they sound the same? And in general, if we didn't have categorical perception, you would expect all the responses to be the same, no matter where you are on the continuum. If you're just changing it by 10 milliseconds, people should be saying either, yeah, that's definitely the same because it's too short for them to tell the difference, or yeah, that's different, or somewhere in between, but it should be level no matter where that 10 millisecond difference is coming along. But what we actually find is something like this. When you get to whatever that boundary is in the language you're examining, people get much better at telling apart sounds, even when the actual difference hasn't changed. So 10 milliseconds, 10 milliseconds, 10, 10, 10 milliseconds. But when that 10 milliseconds starts to bridge a category boundary, right, you're moving from the range we expect to hear for ba to the range we expect to hear for pa, suddenly listeners are really good at picking up on those little differences. So discrimination tasks have that characteristic bump that, like that S curve, indicates categorical behavior in the perception. And there's other ways to get at this as well. Reaction time studies. So if we're asked to tell the difference, we'll be much quicker at telling the difference in that transition zone where you're straddling that boundary than elsewhere. Goodness ratings. So, here's a pa, how good does it sound? It's going to sound less and less good. And then you're going to switch and it's going to sound like a good example of ba. And somewhere in between, you'll have a transition. Different ways of getting at this same idea. And we find generally that consonants show categorical behavior and perception, but perception on vowel stimuli shows a more continuous pattern. So that more straight line thing in the identification task, more flat line in the discrimination task. Now, another really important question for linguists generally and for phoneticians in particular is speech special? I mean, of course, speech is special, but is there something in the brain that's sort of set aside as already pre-programmed to deal with speech differently? That's the special mechanism account. Or are we just drawing on the same perceptual abilities and mechanisms that we do when we're perceiving anything else in the world around us, whether it's not linguistic, maybe not even social, just perceiving inanimate objects, other animals, that kind of thing? Are we drawing on general perception and just using it in a special way for speech? Or do we actually have something that's predestined, prepared to be separate for our perception? And this question is pursued in various ways. We can look at really young children, young infants who haven't yet acquired language, and so maybe they treat speech like other phenomena in their environment that they're trying to perceive and understand. Because they don't have language, we need to find other ways to determine what they're actually perceiving. And you can look in the textbook for the high amplitude sucking paradigm, which is very fruitful and gives us really useful information at very, very early ages, just a few weeks or even days old. Another way is to construct special perceptual situations that aren't speech, but that share properties of speech. So, for example, we can examine stimuli that vary by tone onset time, right? Something other than voicing. Maybe we have different tones, and the relative starting points of different tones varies in a way that is parallel to the varying in voice onset time? And do listeners' perceptual behavior does the perceptual behavior look similar or different across these speech versus non-speech sets? This can help us understand if there's a special mechanism or not. And a third way is to look at how other animals perceive the speech stimuli that we've exposed our human listeners to. What sort of patterns do they show in their perception? How does that compare to the patterns we see from human listeners? And that again, if you have a species that doesn't have speech at all, you know that they don't have a special speech mechanism. Um, so what what does that tell us? How does that help us adjudicate this kind of question? Right. So we've seen some exemplar-based theories, motor theory. There are auditory theories. There are theories of speech perception which are sort of limit themselves to looking in the auditory realm and not looking at motor uh, mirroring of articulation and that kind of thing. Um, and of course, there is this context-based variability. Some of them try to build a model of cue integration. Like we said, listeners are clearly using multiple sources of information and putting them together to form their percept, to form their idea of what it is they heard. And so any model of perception has to do that. And these auditory theories are uh, no different. So a lot of specific information given in the chapter of the textbook around this. You don't need to know it all inside out, but it is good to get a general sense, get a sense of the themes, the different approaches researchers have taken to try to tease apart these various ideas that are obviously very important for understanding how speech is perceived. And in the final video, the next one for this section, we'll look at the role of linguistic experience in speech perception very briefly.